Hello and welcome to tutorial number 6 of the series. So this time around we already have a working definition, right? So this whole marching cubes algorithm works. So all we need to do now is just extract information out of it and get the statistics. Basically, if we were to build this type of a thing, we would need to know for sure how many elements, of what kind we will need, right? So we need to extract that kind of information. Before I'll do that, I will spice things up a bit, and instead of us using just these simple ones, I'll be using the library that I have created some time ago. I think it was during video number 2 and video number 3 of this series. So I'll just simply reference in my geometry for different of different types into different into separate clusters here. Just set multiple, and all of these, as I'm doing that, I'll talk about it for a bit. All of these are meshes. So I actually modeled them out as NURBS polysurfaces, but I'm referencing them in, so I meshed them and I'm referencing them in as meshes just because it's much faster. So the script will work much faster, the calculations will work much faster, and the renders will not crash, so to say. So that's why I'm doing it as a mesh. But of course you could, as you probably saw, you could do this as a NURBS polysurface as well. Is this number? That's number 10. Wait, did I mess it up? Shit. Let me check. Enable preview. Yeah. Hide these and these. So that's fine, that's good. So number 10. Okay. Let's carry on. And that's a really good thing that I numbered all of these clusters. So that's done. So that's why I'm not using a brep component here or a mesh component here, but rather I'm using a geometry component, right? Empty geometry component here, just so that what's going on here? Rotate that, just so that it doesn't matter what type of geometry I input, it will always work. So that's that. Let's see if that updates properly. Here, let's hide that, hide a bunch of things here. Don't need to see the guides anymore. Don't need to see the points, or actually let's look at the points. Okay. So unfortunately, every time when you do this, you'll need to oh crap. Okay, let's see what's wrong. Let me disconnect the counter for a bit. Red. Oh, that's a brep. Okay, so this is precisely why here I'm using the empty geometry component rather than brep or a mesh component, because you can see here, since I'm right now I'm working with mesh elements, this one is complaining like crazy. But if I were to connect a mesh component here, it would show me the geometry. So instead of like messing with these, all I'll do is just create a geometry component like so, and that's that. Easy. All right. So we have that going on, and there is one null in the list while we're at it, that's a single null, so I'll use clean tree component here in between these two, so it removes all of the nulls from the list, cleans it up for us. Right, so now 79 meshes. Okay, let's move on with the loop. That seems to be doing just fine. Cool, looks nice. Anyway, so here I need to precisely know out of these 160 meshes, how many of them are of what kind of type, right? Because then I can choose what kind of fabricating techniques I'll use to create these. So first thing is, from this point on, right, from here, I'll start treating this geometry as a mesh, right? So if it's a burep, I'll purposely mesh it, right? If it's a mesh, nothing will happen, right? So this will mesh our bureps. Then for baking purposes, I will just simply use mesh join, like that. This is if I want to bake it out as a single mesh, right? And just have a nice preview for it as well. Might as well, why not? All right. So we have something like this, and let's make it full on. Neat. Looks cool. Okay, so we have a mesh. I basically, as I mentioned many times by now, I want to know how many types of elements I have here, right? So there are many ways of how to do it. Of course, you could also say that together with the mesh, the information of which mesh is being used out of these, which type is being used out of these elements is being processed. But honestly, I don't want to make any more wires in this mess. This is as messy as I want it to be. So I'll have this kind of more of a brute force approach, which I think is kind of okay to have. In this case, it won't slow it down too much. Said that, I will be... how do we do this? I will be creating a data dam. So a data dam does, it only lets information through if you press the play button. If something updates on the left hand side, so let's say something happens here, this gets disconnected, reconnected. So some information changed on the left hand side, the play button reappears, and then I need to manually update it. So this will help us with keeping the loop, like this portion right here, as fast as possible. Okay, so now we can move on. Brute force way. I'll go by real fast. So this is a mesh, right? And each mesh is different. Each mesh contains different amount of vertices and different amount of faces. Meaning that for each mesh we can extract the text. And I'll do that, the text of its, of what we see in the list. And I'll do that with a simple text component here, like that. So these are not meshes anymore. This is just text, meaning that I can split the text. Where is it? No, that's compound text split. Split some text into fragments using separators. So I can specify at which separator am I going to split the text. And I assume, let's try using just the oh god, not semicolon. Jesus, forgot the name of it. This guy right here. It's really late in the night now as I'm recording this. Okay, so let's use that. // for a panel. Grab that one. Place it there. So what we will get in doing so is this text is going to be split into these parts, right? Just like that. I also want to use a spacebar for splitting because I want to extract how many vertices it has, and this is the fastest way to do it. So here I will just hit enter and hit the spacebar. So that's an important part, right? So while this is the symbol that we want, that's a spacebar, right? In the second line. There's no third line here. So just 2 lines, 1 symbol, 1 spacebar. Great. Now we have everything separated, which means we can say list item and get me the second item in the list, right? This number. So back here, that's how many vertices, how many points each mesh has, and of course each mesh will have different amount of points. We will be using that, and with splitting with these 2 symbols and using list item to extract exactly the correct line, we just get the numbers, which is really nice for us. Okay, so we have that going on. Now what I need to do, do we flatten? Well, for now let's leave it as it is. Now what I need to do is I need to reference in all of the meshes from my library into one list. So I'll just grab a geometry like that. We will be repeating kind of this approach. So library. Hello, where did you? Oh, okay. There it is. That's our library, and set multiple geometries. And now keep in mind, let me turn on the guide. Keep in mind that it's very important to reference in elements from, the lowest number to the highest, right? So it needs to be, it cannot be random. It needs to be 1, 2, 3, 4, 5, 6, 7, and so on, right? So that's an important part, like that. So 14 elements referenced in, right? And if it's a brep, it should become a mesh. If it's a mesh already, it should stay as a mesh. So we do this. And in this case, since it's only 4 elements, since it's only 14 elements, I can just use deconstruct mesh on these. So you can immediately see this one takes like 16 milliseconds and nothing here, less than a millisecond here, while this one takes 86, right? So if I were to use it deconstruct mesh on 160, well, you can check. I can show you. Bam, almost a second, right? So this saves us a lot of time. Moving on. Need to stop patting myself on the back. Here we have how many vertices each mesh has, right? So that's a vertex, not how many, but actual vertices for each mesh that we have here, and all of them are kind of stacked in the same, like in the correct sequence, which means that if we measure the list length like so, let me actually hide that. We will get a bunch of numbers, right? Which is excellent for us, because this is basically element type 1 has this amount of vertices, vertices, element type 2 has this amount, and so on, which means that we can use this. Okay, so now on to the tricky part. What I want to have as an end result is this type of a panel. Type 1 space dash space 15. Type 2 space dash space 12 or yeah, 12. Type, well, let's just say dot dot dot, type 14 spacebar dash spacebar 4. So for every type of my element I need to have a number, right? And I want end result to be a panel something like this, of course containing all of the results. So I need to figure it out, right? I need to figure out how I can approach this. I do have a way of how to check which element is which in accordance to how many points it has, but I need to start constructing this text right here. So first of all, type 1, type 2, type 14, that's gonna be kind of easy, I think. Let's try. If we just create a panel and we type in type, right? We have something like that, and we can use just the repeat function to repeat it 14 times, because we have 14 elements, right? So what do we get here? Type. That's okay. That's good. So we have the first beginning of the list. Okay, now for the numbers 1, 2, 3 and until 14, that's series of numbers, and we can just say it starts with 1. It starts with 1 and counts 14 times, like that. Okay, so we have something like this, which means that we can join these up. The problem is, if I were to use join text or text join on these two, like that, the answer is gonna be pretty disgusting, right? That doesn't work. We want to have each line separated. And thank God we have 14 lines here, 14 lines here, meaning all we need to do is graft and graft. And actually, let's clean it up. I'll just use merge to merge these two lists so that you can see what's going on. So before merging, we get before joining, we get this kind of a data tree. Type 1, type 2, type 3, blah 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 blah, type 14. And after joining those, we get perfect, right? Type 1, type 2, type 3, blah blah blah. I do want that dash here. So for fragment separator in the join, I will just use the dash like that. It basically just places that symbol in between every text that's being joined. Nothing fancy. Okay, we have that going on, which is super nice. Now on to a harder part. So we need a number. Okay, if we have this list and this one will need to be flattened. Flatten, because I want it to be single list. So let me just have that here. If we have this single list here, and we measure, sorry, I'm a bit scrambling because I'm just figuring it out as I go this time. So that's awkward. Okay, let's do it this way. So we have our our amount of vertices here, and we have our lengths, I guess, here. So that's amount of vertices for every element that is here, and this is amount of vertices for every reference element that we're using, so for every type. If we were to say this is a single list, first of all, no, sorry, that's a single list, first of all, flatten. If we did that, and then we were to ask, is it equal? Is this one equal to this one? Right? And we were checking equality. Then we would get this kind of a true or false statement. So notice how there are 14 statements from 0 until 13, so 14 in total. And here the first one is true, here the first one is true. Some places, in some place, damn, that's a lot of first ones. Yeah, there we go. Here the third one is true. This is which one of the, so it checks per each element that is here, right? So let's say element 1 comes in, which I believe is this one right here. Element 1 comes in and it checks for, is it equal, is its vertex count equal to any one of these? And if it is, then it will return true, which is super perfect for us, because we can then say, here we have true and false statements, and here we're just counting. So what we can do is we can say list, where is it? No, cull pattern. So we're culling the list of numbers, right? We're culling it with the pattern, which is checking, basically saying no for every element, which for any type that doesn't hit it. So here the first one is true, and if I plug it in like so and I check it like that, then I can see here that this is element type 1, element type 1, element type 1, element type 2, and so on. You get the idea. Right, so that's done, and of course we can flatten this out now. So we have a list of 160 elements, right? And each one of them receive a number of what kind of type of an element they are. Very close to the finish line, right? So as we're moving on, we don't care about every individual element. I mean, this is good information for assembly purposes, but we don't really care about that. We just care about how many we have. So what I'm going to do is I'm going to say, that flatten comes in here, I'm going to say for every number, and remember, since this is grafted, these are separate numbers. So for every number, is it equal, again checking that equality, is this number, every number, equal to these numbers, right? Like that. If I do this, what I get is a crap ton of true and false statements, which basically just goes through, okay, element type 1, right? Because here we have number 1 as our first input in the list. Element type 1, okay, it goes through every single element here and it asks, are you element type 1? Are you? Are you? Are you? And so on. And here every element which is element type 1 is going to answer yes or no, right? Which means, and then it goes through, okay, so now for element type 2, goes again through the whole list and asks, are you element type 2? And also receives answers yes or no. Which means that we can use mass addition for this. And keep in mind that true or false statements is the same thing as ones and zeros, meaning we can add up all of the ones that are saying true, right? And if we add them up, we know how many are saying yes I am element type 1 or yes I am element type 2, right? So here we get this list. Nice. Okay. And I wanna kind of clean it up a little bit, because here you can see there's a bunch of like zeros after the there's a bunch of zeros in the data tree addresses, so I'll just clean up both of these by just choosing simplify on the outputs like that, and now you can see everything is very clear. So now all I need to do is join these two guys up, right? Type 1 dash 50, type 2 dash 56. Okay, that's a simple merge. Like that. Hey, come on. Stop it. Okay, there we go. That's a simple merge. And that's a simple text join again. And this time for the join, I will be using spacebar dash spacebar. That's not a dash. Where is it? The diagonal one is a slash, so this is a dash. Minus, I guess, spacebar minus spacebar. And now the answer is gonna be pew, just like that. I'll of course flatten everything like so, and zoom in here, make it central, like center point snapping thing. Remove the side, remove the top, and make this white. And maybe make it bold and bigger. There we go. So let's create a cluster. Before I do that, I remember that here I have 160 elements, right? And here I have a type for every element. I will kind of hold on to that information. So I'll just create a text component, empty text container, sorry, and just kind of move it here, just if I need to have it, right? Because it's kind of rough taking out information out of a cluster once you've done it. So everything here is, how do you say, everything here is automated. You don't need to do anything, meaning that what we can do is just simply select all of these, except mesh here and geometry here, and text here and the panel here, of course, and just middle mouse click, and at 12 o'clock you'll see cluster icon. You click on that. Perfect. Cluster. Here I'll just name it a little bit so that it's easier to understand what's where. So text is going to be not a text, but actually all elements. No, how do you call it? Aggregate. How does it spell aggregate? Probably something like that. Let's just call it aggregate. So this guy, right? We plug that one in. This one is going to be element library. Okay. The output, this one is going to be element type count, and the last one, this one is going to be type of each element. Okay. So we have everything cleaned up, and honestly, at this point, it's up to you to design whatever you want, because you can change the whatchamacallit, the point cloud easily. So for instance, oh yeah, and keep in mind that here you have a data dam. So if you want to actually preview it properly, I would suggest having the mesh join, like this part, before the data. No, having mesh join here is fine, but having the preview of it, copy paste right here, is much. Let me just delete that. Is much better. Just so that when the loop runs, it automatically updates the preview. So what I was saying was, for instance, I can choose to take some of the cellular automata points, ungroup them, and let's just say I'll just delete these, whatever, and run this again. Right, and you can see how it reacts to it, meaning that you can extract any point cloud. In this case, we are using the cellular automata marching cubes algorithm from the previous tutorials, but you can floating. But you can extract any point cloud you want, right? And as long as the gaps between them are exactly 10 units. So it needs to be a voxelized point cloud, but you can design with this in a sense that if I were to move this by 10, or sorry, copy this by 10 units, and now I run this again. So that part was, how do you call it? Separated, right, from the remainder of the structure. And now as I move the, what the heck? Why do, oh right, you know what's good? When you create a point, actually referencing in the point into Grasshopper and then running it. Yeah, that would have been smart to do. Let me grab a drink while this one runs. And there we go. So see, just by adding that one point, I have created a connection between these two, between this element and the overall structure, and I can, you know, start thinking about it, start modeling with this, and it's always going to make a closed surface for me, which is a really nice thing. Really enjoy it. So that's that, I guess. I will be doing one more tutorial for rendering, so keep an eye out for that, but that's going to probably take me another week to do. And for now, you have all of the tools necessary to do anything, right? Really, with this approach. As always, I'll be speeding up now the remainder of the video, while I'll be just creating a intro screen. So if you're interested to see how that intro screen was made for this particular video, you can stay around and just look, I guess. And that's about it for this particular task. Again, all of the tools are gonna be in the description, all of the files are gonna be in the description, and I'll see you guys next time. Bye.